All right, guys, so I couldn't be here today, so I'm going to go ahead and try to do these notes with a video for you. So we'll see how that goes, all right? So today we're going to be talking about solving multi-step inequalities. We've talked about multi-step equations before, and it's basically the same thing. We took a quiz yesterday on 3.3, and that's the only thing that you need to keep in mind here as we're doing the inequalities. The 3.3 stuff was about anytime you multiply or divide by a negative number, you need to remember to flip your sign. Other than that, it's exactly like what we've done with the multi-step equations over the last few weeks to a month. Okay, so here we go. It says you solve a multi-step inequality in the same way that you solve a one-step inequality. You use the properties of inequality to transform the original inequality into a series of simpler equivalent inequalities. All right, I'm going to try to go through these a little bit faster because I've actually gone through these notes 3 times now, trying to record this for you, and I keep having issues. And so because of that, I'm going to try to go through these a little bit faster, and hopefully whoever's in here with you during the hour can go ahead and pause these where they need to, okay? So problem number 1 is n plus 4t, which is greater than 21, all right? We have the option of drawing that line in if we want to. We want to subtract 9 on each side so that it's the same, keep that inequality balanced. The 4t drops down, which is greater than 12. We want to divide each side by 4, so t is greater than 3. Okay, like we've been doing in 3-1, 3-2, 3-3, we go ahead and bring that over to the side, pick a number to go on each side of the 3. We make our circle, we don't fill it in because it does not include 3, and we shade to the right side. And that's it. Okay? Number 2, we've got 3x minus 7, which is less than 8. Okay? So again, we're wanting to get rid of the 7, so we're adding 7 on each side so that it goes away on the left. 3x drops down, less than drops down, 8 plus, that kind of looks like minus 17, okay, plus 7 is 15. Divide each side by 3, and x is less than 5. Take that over here and graph. Again, circle is not shaded in. This time we're shading to the left since we have a less than symbol. Okay, number 3, we've got negative 6y plus 5, which is less than or equal to negative 16. The tip that I started off with at the start of the day is remember that anytime we're dividing or multiplying by a negative number, we switch our sign. Okay? So here we go. Subtract 5, subtract 5. We have negative 6y, which is less than or equal to negative 21. Divide each side by negative 6. Our y value, okay? Notice this tip, right? We're dividing by a negative 6, so we have to flip that sign from less than or equal to greater than or equal to. And negative 21 divided by negative 6 is 3.5 or 3.5. All right, take that over to the right side, 3.5 in the middle, 4 to the right, and 3 to the left. Our circle this time, because it includes the 3.5, gets shaded in, and we're shading to the right side. Okay. All right. So those are pretty quick and easy, two-step equations. All right. Or sorry, not equations, but inequalities. Again, it is the same thing as the equations that we've already done. We've already had a unit test on. Most of you did really well on it. Okay. So I think this is just more of going through the motions here. All right. So please remember that anytime during this video, you need to stop, you need to raise your hand and ask a question. You are more than welcome to do so. All right, so pause and move about this video as you need. All right, so here we go. Problem number 2, writing and solving a multi-step inequality. It says in geometry is what we're working with here. It says in a community garden, you want to fence in a vegetable garden that is adjacent to your friend's garden. You have at most 42 feet of fence, okay? So at most is important to us. What are the possible lengths of your garden? we need to know the perimeter formula. So P is equal to 2L plus 2W. All right, we have a length and a width. It's asking us to find the length. So I'm going to scroll down here just a little bit so that I can have a little more room. So we are going to take 2L plus 2W, which is less than or equal to 42. Again, I'm trying to solve for the width. If we look here in our picture, we have a W value, the width, which is 12 feet. So we're going to plug that into our equation. So 2L plus 2 times 12 is less than or equal to 42. We go ahead and get rid of the 2 times 12, which is 24. We're going to subtract 24 on each side. And then 2L is less than or equal to, let's see, what would that give us there? 18? And then we want to divide by 2. So L is less than or equal to 9 feet. Okay? And because it's a real world problem, we want the answer of 9 feet. Okay? All right. Letter B. You make a rectangular banner that is 18 feet long. It says you have no more than 48 feet of trim for the banner. What are the possible widths that we can make the banner? Again, this is a perimeter question, so we're using the 2L plus 2W. It says that it's 18 feet long, and we have no more than 48 feet of trim. Okay, so we need to use less than or equal to 48. We want to go ahead and take our length and plug it in with 18. Again, if I'm going too fast, I apologize. Please just go ahead and pause the video, okay? So 2 times 18 is 36, plus 2W is less than or equal to 48. We want to subtract 36 on each side. The 2W drops down, which is less than or equal to 12. We want to divide each side by 2, and W is less than or equal to 6 feet. And again, because it's a real world problem, we want the 6 feet. Okay? All right, so real world problems, again, same thing as those equations that we did, not too challenging and difficult here. Okay? It does get more challenging and difficult when we're dealing with these problems that look like number 3, because you can see we're going to start incorporating the distributive property. Okay? Remember, distributive property means we're going to multiply the number out front by each term inside of the parenthesis. And that's what a lot of people make a mistake on. They forget to multiply each and every term. Okay? So here we go. 3t. 3 times 1 is 3. Subtract 4t, which is greater than or equal to negative 5. All right? Anytime we're doing these, we want to see if we have like terms before we start to actually solve the equation. And I notice that I have 3t and a subtract 4t or a negative 4t on the same side of the equation. So we need to put those together first before doing anything else. Okay? So 3t minus 4t is negative 1t. The positive 3 just drops down here, which is greater than or equal to negative 5. I draw in my line if you want to split it to the left side and the right side. I subtract the 3, get negative 1t is greater than or equal to negative 8. And again, we have this negative 1t, so we don't want negative 1, so we need to divide. Notice again that I'm dividing by a negative number, and what we talked about in 3.3 is anytime we divide or multiply by a negative, we have to switch our sign. So the greater than or equal to becomes less than or equal to 8. Take that over, 8 goes in the middle, 9 to the right, 7 to the left. Circle, we shade it in, and we move this to the left side. Okay. All right, there we go. Again, please feel free to pause the video if need be. Letter B, we want to distribute each term. Okay, negative 0.6x plus 3, because negative 0.6 times negative 5 becomes positive 3, which is less than or equal to 15. We have no like terms this time, so we're ready to go ahead and start solving. So we subtract 3, which gives us negative 0.6x, which is less than or equal to 12. We divide by negative 0.6. And again, we're dividing by that negative, so we flip the sign, and that gives us negative 20. All right, so x is greater than or equal to negative 20. Please don't forget that with our negatives, remember negative 19 goes to the right, negative 21 goes to the left. We've got our circle. This time we're including negative 20, so we shade in our circle. And we're greater than it, so we're shading out to the right side. Okay, C, again, distributing the parenthesis to each term inside of the parenthesis. Okay, so we get negative 1/4 of P plus 3, which is greater than or equal to negative 2. We're ready to solve since there's not like terms on each side. We subtract 3. We bring down the negative 1/4 of P, which is greater than or equal to negative 5. To get rid of a fraction, hopefully you guys remember, we go ahead and multiply each side by the reciprocal. So the reciprocal of negative 1/4 is 4 over negative 1, or also known as negative 4. They cancel out over here on the left. Again, the number I'm choosing to multiply by on each side is a negative number. And so because it's negative, we flip the sign again. So greater than or equal to flips to less than or equal to. And if I take negative 5 times 4, I get negative 20. And then on the bottom, I would have 1 times negative 1, which is a negative 1. And negative 20 divided by negative 1 becomes positive 20 for the answer. So 20 is in the middle, 21 to the right, 19 to the left. Circle is getting shaded in, and we shade to the left. All right, letter D is the last one here with some distribution that we're going to talk about in this section. Okay, so the left side of D can't do anything with, so I drop it down. The right side, I bring down the 5. And we've talked about this a lot this year. Okay, we've got this 2 out in front of the parenthesis, but notice that it has a subtraction sign in front of it. So we really want to think of that as a negative 2 when we're distributing to each term. So it's negative 2 times 4, which is negative 8m, and negative 2 times 7, which is negative 14. All right, again, we noticed that, or hopefully we noticed that the left side doesn't have like terms, but on the right side we do. I've got a 5. And I have a subtract 14 or a negative 14 that need to combine. Okay? So when I combine those, we end up getting 15, which is less than or equal to negative 8m minus 9. Okay? All right, we're going to add 9 here on each side, which would give us 24 is less than or equal to negative 8m. And I'm dividing by negative 8 on each side. So it becomes negative 3, and be careful again, we divided by a negative, so that less than or equal sign switches to a greater than or equal to m. Okay, you could leave it like that, but as we've talked about in 3.1, 3.2, and 3.3, sometimes that letter on the other side of the equation throws people off. So if you want to rewrite it, m would come first. We flip that sign back to less than or equal to negative 3, and then we graph it. And over the top of negative 3, we're coloring it in because it includes negative 3, and we're less than that, so we're shading over here to the left side. All right, so again, reminder, I'm trying to go fast. I've already spent a couple hours trying to get this set up for you guys before I leave school here tonight. So if you need to pause these, please feel free to do that. And I also will have this linked up to the homework website so you can come back to it later if you really want to do this over the weekend, okay? I know you'll all be so excited to do that. All right, so here we go. Problem number 4, okay? In these type of problems, we have variables on both sides. We did a lot of this with our equations as well. And, hopefully you remember when we get to equations or inequalities with variables on each side, we will have some of those special type equations that are the all real numbers and the no solutions. We're not going to get to that right now in this group, but the next set of problems we will have some of those. Okay? All right, so first thing you always want to do is look for those like terms. Left side, no like terms. Right side, no like terms. So we want to move the smaller of the two variables. Remember, that isn't something that you have to do, but it is something that is helpful. All right. So 3n is smaller, so we go ahead and subtract 3n. That leaves us 3n minus 1, which is greater than 8. We add 1 on each side. We have 3n is greater than 9. Divide each side by 3, and n is greater than 3. We take that over here. We put 3 in the middle, 4 to the right, 2 to the left. We circle the 3, and again, we're not shading it in because it doesn't include the 3. So we shade to the right side. All right, B, same thing. We don't have like terms on the left or the right. Our smaller variable is 2x, so we want to subtract 2x on each side. Gives us 4x minus 7, which is greater than 17. We then want to add 7 on each side. All right, this goes away. 4x drops down, greater than 24. Divide by 4, and x is greater than 6. All right, so 6 in the middle, 7 to the right, 5 to the left, circle. Not shading it in because it doesn't include 6. Greater than symbol means we're shading to the right. And that's it. All right, next page. Again, please feel free to move, or not necessarily move this, but pause it and then come back to it. Do whatever you need to make this work for you, okay? All right, letter C. We've got 5x minus 12 is less than or equal to 3x minus 4. Left side, no like terms. Right side, no like terms. Smaller variable is 3x, so we move it. Goes away on the right. 5x minus 3x is 2x. 2x minus 12 is less than or equal to, be careful here, we've got that subtract 4, so don't forget to bring that subtraction sign down and make it a negative, okay? Add 12 on each side now. We have 2x, which is less than or equal to 8. We want to divide each side by 2. X is less than or equal to 4, which we then graph. 4 is in the middle, 5 to the right, 3 to the left. Circle over the 4, shade it in. And less than means we shade to the left. All right, so letter D. Again, no like terms on the left side, no like terms on the right side. Draw our lines, we start moving things around. 3b or negative 2b, which one is smaller than negative 2b? So we want to add 2b on the right, and on the left, 3b and 2b becomes 5b. We want to subtract 12 on each side. 5b is now greater than or equal to 15. Divide by 5. And b is greater than or equal to 3. 3 goes in the middle. 4 to the right. 2 to the left. Circle it in. Shade it in because we include 3. Greater than means we shade to the right. Again, really apologize for how quickly I'm going through these, so please feel free, pause it, rewind it, do whatever you need to do to make this work for you to get these notes down, okay? All right, the last, basically the last thing we're going to talk about here are the inequalities with special solutions. I alluded to this just a few minutes ago of the fact of, you know, when we have equations with variables on both sides, sometimes we get a problem that has all real numbers that could possibly be plugged in, and it would make a true statement. Sometimes we have, no matter what number you plug in, it will give you a false statement and make it, you know, something that does not work. So, The difference with these is in the graphing. Notice that we don't have like any circles that are colored in and that kind of stuff. We've just shaded the entire line, left side to right side, for something that is an all real number. Okay? And over here on the right side, for something that is a no solution, we just pick some numbers on the number line, and then we don't do any shading at all. Okay? So here we go. The number of solutions. If an inequality is equivalent to an inequality that is true, such as -3 is less than 0, then the solutions of the inequality are all real numbers. So, true statements mean all real numbers. Remember, we can abbreviate that with ARN. Okay? If an inequality is equivalent to an inequality that is false, such as 4 is less than -1, then the inequality has no solution. Okay? So, true statements, all real numbers. False statements, no solution. All right, down to the bottom. Directions. Solve the inequality if it's possible, and then graph the solution. Okay? So this is going to combine all of the things we've talked about so far. Some of them might have some negatives that we need to flip the signs. We have distribution. We have variables on each side. Okay? All right, here we go. 10 minus 8a just drops down, but I need to get rid of the parentheses by distributing the 2. So 2 times 5 is 10. 2 times 4, or 2 times -4 is 8a. Okay? All right, we should notice at this point, I don't have like terms on the left, I don't have like terms on the right, but we should notice that I have the same variables. Each side will get rid of the variable, and that's when we have these special types of either no solution or all real numbers. If it's a true statement like this one, 10 is greater than or equal to 10, it's true, and true means all real numbers. Anything we plug in would work. Okay? So, to make it really simple over here when we graph it, use -1, 0, and 1, and we shade all the way across the line, and we put an arrow on each side. And that's it. All right, our next one there, we want to go ahead and distribute that 7 again. So we're distributing the 7 on the right side. 14x plus 5 on the left side drops down. 7 and 2 become 14x. 7 and -3 is -21. Okay? All right, again, no like terms on the left, no like terms on the right. We notice that we have the same variable again on each side. So those go away, which leaves us 5 is less than -21. That is a false statement. A false statement means no solution. So to graph no solution, we put -1, 0, and 1 on the line, and that's it. We're done. There's no shading, there's no graphing. You just put some numbers on the line, and you move on to the next problem. Okay? All right, C. We have 12x minus 1, which is greater than 6 times the quantity of 2x minus 1. We want to distribute the 6. All right, so we again don't have like terms, so we want to move the 12x. We notice that they're the same. -1 drops down, which is greater than -6, and we ask ourselves, is it true or is it false? So that is a true statement. A true statement means all real numbers, which I'm going to abbreviate this time. -1, 0, and 1 on our line, and we're shading the entire thing from the left side to the right side with an arrow on each side. Okay, D. This time we don't have parentheses to get rid of, but we do have like terms for the first time. They're not on the left side, but over here on the right side we have a 7m, and then we have a minus or subtract 1m. So those two things need to go together first before doing anything else. So the left side just drops down. 7m minus 1m is 6m. We notice that they're the same variable again, so when we go to move those, they both go away, which leaves negative 5 is greater than 7. That is absolutely not correct, so that's a false statement, which means no solution for our answers. And again, with a no solution, we literally just pick any numbers we want to put over there in order, and we don't graph anything at all. Okay? All right, so for practice, okay, we've got a few questions here that will help us kind of, wrap everything up all at once, all right? So 5 times m is 5m, 5 times 5 is 25, which is less than 5m plus 17. We notice, again, no like terms. However, when we go to subtract the smaller variable, we notice that they are the same. The 25 drops down, which is less than 17. We notice that that is a false statement, which again means no solution. So, random numbers in order, no graphing, and that's it. All right, the next one. Again, we want to get rid of the negative 4 by using that distribution property, okay? 1 minus 8s. I'm writing s in a cursive s so it doesn't look like a 5. Less than or equal to negative 4 times 2s is negative 8s. Negative 4 times a negative 1 is positive 4, okay? Again, left side, no like terms. Right side, no like terms. Move the smaller variable. Notice, oh, hey, these are the same, which means they're both going to go away. The 1 drops, which is less than or equal to 4. So 1 is less than or equal to 4, which means it's true. And that means we have all real numbers for our answer. Okay? Pick anything to go on this line as long as it is in order. And we shade from the left side all the way across to the right side. And we put arrows on each end to say it continues forever. All right. Number 3 is the car wash, okay? This is kind of common when you go to a Shell station. I know Quincy Shell station has that, all right? So it says use the sign show, and it says a gas station charges 10 cents less per gallon of gasoline if the customer also gets a car wash, okay? What are the possible amounts of gallons of gasoline that you can buy if you also get a car wash and can spend at most $20, okay? So at most $20, and we're getting 10 cents less per gallon. Right now, gasoline costs $2.09, but if I'm going to get a 10-cent discount, we're going to subtract that for every gallon that we buy, as long as we add the $8 car wash. I don't want to spend more than $20, so I use less than or equal to $20. All right? Because the gasoline price is in parentheses, we're going to do that first. So $2.09 minus 10 cents leaves us $1.99 per gallon, plus the $8 for the car wash, and I'm still trying to spend less than $20. We subtract the 8 from each side. So $1.99 is less than or equal to 12. We divide each side by 1.99. And we end up with G is less than or equal to some big long decimal like 6.03015, and it continues. All right. So what does that actually mean? Okay, if we're just trying to get the easiest amounts, full gallons, we could have anywhere from 0, 1, 2, 3, 4, 5, or 6 gallons of gas. Okay, so 6 is, or sorry, not 6. G is less than or equal to 6 gallons. All right, so that's one way to do it. On the back of this sheet is actually another way to do it. It doesn't really matter which way you decide to do this. when it comes to these real world problems. Sometimes solving it algebraically, like we just did, is easy. Sometimes using a chart, like on the back of our page, is easier. Okay? So take a look at the chart. That's another way to do it. You could think of this out fairly easy. If I didn't buy any gasoline, but I still had to get that discount, okay, we're going to use that car wash, right? That is an option. I don't know why you would spend $8 for the car wash and not buy any gasoline, but you could do that, okay? All right, over here, $1.99 times 1 gallon. That would give us $9.99. And if we continue this pattern, it would be 11, 98, 13.97, 14.96. No, sorry, 15.96, then 17.95, and 19.94. Okay, and all of these are in dollars. So you can see at 6 gallons, $19.94 is just below $20. Okay? All right, the last one here, camp cost. It says you're saving money for a summer camp that cost you $1,800. You have saved $500 so far. And you have 14 more weeks to save the total amount. Okay? What are the possible average amounts of money that you can save per week in order to have a total of at least $1,800 saved? All right, so we now have $500. We have a total of 14 weeks left, and I want to save at least $1,800. We're subtracting 500 from each side. We're dropping down the 14W, which is greater than or equal to 1,300. We're dividing by 14. And W is greater than or equal to approximately $92.86 per week. Okay? So it says, on average, what do you need to save every week? Basically, $93 a week. Okay? So $92.86 if you want to get technical. All right, so that wraps up our notes here for lesson 3.4.